as per the specification and customer's requirement. Finally, pipes are kept ready for final inspection, and after acceptance of
Hello.
pipe by quality
If you can
assurance,
cut short
the
your
same
video,
is
please,
shifted
you
to
can
the
cut short
dispatch
your
yard
video.
for dispatch. Rungta Mines has in-house quality testing facility for testing following tests: tensile test, elongation test, Brinell hardness test, and microstructure check. Known for its best-in-class quality and advanced manufacturing techniques, Rungta DI Pipes continues to exceed industry standards by offering innovative solutions tailored to shaping India's water infrastructure. With a standard length of 5.5 meters, size available DN80 to DN1000 for class K7 to K9. These DI pipes are designed to handle high-pressure applications, making them ideal for diverse uses. They are crucial for portable water supply, efficiently transporting water from surface sources like rivers, lakes, and reservoirs to households. As an environmentally responsible company, we prioritize innovative technologies for sustainable development. We rigorously implement resource efficiency and climate change mitigation strategies to minimize waste generation and greenhouse emissions. We are very much anxious to serve your next requirements for ductile iron pipes, assuring you of our best products and services at all times, and eagerly wait to hear from you at our below mentioned contacts. Thank you for watching.
Thank you. Thank you so much, everybody. Hope you have liked the presentation, a small briefing about the production process of ductile iron pipes in our factory at Chaliama Steel Plant, Chaivasa, Jharkhand. In brief, we would like to inform you all that we have been accorded with BIS license for DI pipe in compliance to IS 8329 in the month of July 2024. And for the diameters ranging from DN80 to DN1000, we have an installed capacity of 5 lakh tons per annum. It gives us immense pleasure to share with you that we have received approvals and got empanelments in various state government departments and water authorities, and many are under process. That makes us eligible to participate and also to serve your requirements. This gives us a confidence with a strong conviction that we will meet the expectation of various end users in different water supply, sewerage, and irrigation projects, thus contributing towards reducing the supply and demand gap, which we have witnessed in last years also. Under stringent quality check parameters in accordance to the BIS specifications, we are committed to deliver best quality DI pipe to our customers. We are available for any kind of assistance and services. Right now, we are having our stall at stall number 4 and 47. Please do visit us
Gentlemen, kindly.
at
kindly
our
come.
stall. And thank you very much for your patient hearing. Thank you very much, IWWA, for providing us such a beautiful platform to share the knowledge. Thanks. Thanks to everybody.
Right. Thank you. Thank you. Wonderful presentation. I request the delegates also, they can visit the stall of this Ran Gupta DI style. Now next, yeah, Gupta साहब बोलने कुछ है? अभी now precise, yeah.
A small notice is there, especially for the exhibitors. Honorable Deputy Chief Minister will be visiting exhibition between 3 p.m. to 4 p.m. All the exhibitors are requested to present at their stall to interact with him. So anyway, we are circulating also this notice to each stall, but I thought it is better that it is informed to you here also. So those who are present, just see that they have the chance to interact with the Deputy Chief Minister. Will be visiting between 3 to 4:30 today.
Yeah, thank you, sir. Now, the next two presentations also, the organizers are informing us that to be concluded by 11. Now, in place of precise engineers, now DRA consultants from Nagpur, I request the DRA people to come up immediately and try to finish in 10 minutes, please.
Good morning all and warm welcome to the 57th annual convention of the AIBA, hosted in the vibrant city of the Raipur, Chhattisgarh. It is a privilege to have the platform to bring together the esteemed professionals, experts, engineers, and the innovators from the water and wastewater management and the environment industry. The convention provides a unique opportunity to share the ideas, discuss the challenges, and explore the cutting-edge solutions for sustainable water, wastewater, and the environment sector. At this significant gathering, we are proud to introduce DRE Consultant Limited, a leader in urban infrastructure and water, wastewater, and in environment sector since last 34 years of excellence. I am Chief Operating Officer Rajesh Nagpure of the company. Our company is the first Bombay Stock Exchange listed engineering consultancy firm. And we are the trusted partner for the numerous national and state level projects. DRE Consultant Limited has been in the forefront of the transformation initiatives such as Indore Sewerage Project, Nagpur Recycle Reuse Project, Nagpur 24/7, 25 years full city lease contract, and many more. These projects have set benchmarks in achieving the water sustainability and urban development goals. We look forward to meaningful discussion and collaboration during this convention. I thank AIBA for providing this opportunity to share my company profile and extend my congratulations to everyone attending this AIBA convention and wish you all the productive and inspiring event. Thank you. Brief about my company. It's 34 years we are in this field. Earlier it was known as Dinesh Rathi and Associates. Dinesh Rathi sir is our chairperson now. And his managing director, Mr. Aditya Rathi, is leading the consultancy. We are the IMS certified consultancy firm. We are empaneled with all the government organizations, MOD, Smart City, Namami Ganga, Hriday, and various state governments also. We recognize as a water plus city for Indore. So we are the consultants since 2014 there. Water and sewerage, both we are handling there. Nagpur Sewerage Recycle Projects, one of the remarkable and the signature projects of DRE Consultants. We are also having the 12 successfully completed PPP projects which are ongoing. We are also ESCO company, ESCO Grade 2 company. We are there in water audit and energy audits. We have done numerous works in this field and won very national and state level efficiency awards also. Our domain expertise is NRW reduction, 24/7, recycle, reuse, river rejuvenation projects, reuse and energy efficiency projects. We believe in 3R and 3Ps. It's reduce wastage, recycle it, reuse, and public-private partnership. Our expertise services include source augmentation, new source. Basically, this is the requirement of today's, basically, many cities are searching for the new water source or additional water, and we do consulting services in this. Recently, we are working for Pimpri-Chinchwad Corporation, where we have done the existing system augmentation schemes also, and we are identifying the new sources or new dams for the city, considering the year like 2031 or 2041. We are also do the complete hydraulic modeling, designing for the water supply system, sewerage system. We also do some augmentation, some upgradation of the existing STPs. Recently, we are working on the Pimpri-Chinchwad Municipal Corporation. Various departments we are prepared, and some one-by-one pilot study we are taking as a case studies. Also, we are in water, wastewater, recycle, reuse projects. Nagpur signature project is already there. Bulk transmission and storage also we are doing. We are augmenting the additional ASRs, restructuring the existing transmission and supplying water to the ASRs. Automation and SCADA. Indore automation and SCADA means bulk tapping points we have automized, and it is being controlled as a SCADA-based system. So lean demand or the, whatever the actual demand, we are also managing through this SCADA system. NRW leak detection we have done in Nagpur, pilot project also, and the full city is already going on. In Pimpri-Chinchwad also, we are doing for some 5,000 connections we identified. 1,000 connections are already below 20% NRW now. Continuous pressurized system, we are entire PCMC, we have designed for this pressurized water supply system. CCV technology we are using in sewerage system. Nearly 50 kilometers of sewerage network we have surveyed or condition assessment done to this CCTV technology.
Gentlemen, try to,
Yes.
in a couple of minutes, please close.
Survey, drone, GPS, everything we are doing, GIS mapping, condition exception we are doing. Tariff police and bylaws also we are doing Nagpur. We have done for Indore city also we have done the tariff bylaws also for the Indore city. Transaction advisory, water and energy audit. So all spectrum of services we are providing here. Our network offices are, our head office is in Nagpur. Pune office is there, Raipur division we are also there, some Kolkata, Noida, some Mumbai also for MMRE project we are working there. Some Pune city is there, Indore city is already there. Some of the empowerment and esteemed consultant of all the government organization or the state governance, we are already in panel and working. These are some awards and recognition that our consultancy organization has won. That is 24/7 NMC Nagpur City BPP project, Nova Water 2009, it has been awarded. Best performing city under genuine projects, we have been awarded for Government of India. Water Plus City is Indore. And then best practice PDMC.
Try to close.
Yes.
Try to close. Yeah,
So we have the experience, expertise,
this
professionals.
may not
Are
be required. No, this may not be required to the audience. You are basically the master plan consultant for
Yes, sir, yes.
water supply and sewerage. I think you try to wind up.
These are the projects which are approved. Means from the start, from the commissioning, we are doing complete solutions, right from the DPR preparation, funding, and everything. Our water projects are nearly 1,500. Sir, very small, very small.
Yeah, may not be required this information to. Yeah, quickly.
Yes, sir. So nearly in Amruti schemes, 6,000 crores of projects, DRA projects have been approved, and it is sanctioned. It is under ongoing projects are going on. In PPP, there are so many projects, right from NMC, then Delhi Jal Board, we have done some NMC in Bus City. So all kinds of services we provide. This is regarding some Indore city. We are doing some Khan and Sarvaswati river pollution abatement project. It has been awarded. It is well known to everybody. Some water use projects also we have done. 102 MLD, 52 MLD we are providing to farmers. These kind of schemes are there. You can see some before and after scenarios from the our DRA projects.
Yeah, time up, please.
Yeah.
Please go.
yeah.
Please go.
This is also PCMC city. We have done the complete GIS mapping and the DPRs of nearly 1,500 crores are ready. Some Nala diversion interceptors we are doing. Complete river batching catchment and then Nala, dry Nala, making this our objective. All the tappings that we mark, I quickly go through this. These are the tapping points we are arresting. So detailed investigation survey route level work we are doing. This is the Andhra Bhama scheme for Pimpri Chinchwad, which is already going on. It is sanctioned under Amrut 2 Yojana also. Leak detection NRW schemes, automation SCADA, complete GIS mapping. In Chennai Metro Water also we are doing some willingness to survey and quality, water quality and water quantity survey. Thank you, sir. Thank you. For any queries?
Right, thank you, thank you. Give a big applause that really they are the master plan consultants on water supply and sewerage. Thank you. Sorry, please. Yeah, the next the presentation is by Majors Fundamental Technology Pondicherry. Please, sir. Are they available? Yeah, please.
As we conclude the session, I invite A.K. Gupta sir to please felicitate Dr. M. Satyanarayan and Sri Rupesh Dhananjay with the memento and shawl.
Next. Enter, come. No. Next presentation is not there? No. Next presentation from Pondicherry is there or not? She's closing the session. No, whether the last presentation speaker is available or not. That you please tell. If it is not there, I think we can wind up. If it is not there, we can wind up. साहब गुप्ता साहब आप नहीं फंडामेंटल टेक्नोलॉजी साहब अभी हमको
fundamental technology.
ठहरो okay then it's happy sir right okay now just a minute Amma, just a minute. So I think we have a wonderful 3 presentations in this session. The first the session is on pontoon, Wari pontoon. So absolutely it is just like in all during the summer, when the reservoir levels goes down to the below MDDL, so normally this contingency is being arisen to have in a temporary installations lifting the water below this thing. Even in Hyderabad also the last year, the similar situation has come and we have arranged in our Himayat Sagar and other places. And other two presentations we need not to tell. This is one is good on DI pipes and steel, and third is on master plan consultants. Yeah. With this, I think my co-chairperson, our Rupesh Dhananjay ji, is an executive engineer. He has made a good note of it. Thank you. Thank you. I'm concluding the session, please. Okay. Right, Amma. Now you can further say.
As we conclude the session, I invite A.K. Gupta sir to please felicitate our chairperson and co-chairperson. Now I request Dr. M. Satyanarayan and Sri Rupesh Gupta to present the memento and bouquet to the presenters. Vari Pantoons Private Limited. Vari Pantoons Private Limited. Rungta Mines Limited. And DRA Consultants. Vari Pantoons, Rungta Mines. I request you to come to the stage, please. Okay. Okay, thank you. With this, we conclude the third commercial session, and the next session will begin in 15 minutes.
the technical sessions will be in parallel. So one session will be held here and another will be on the first floor. So at 11:15, the two sessions would be there. Dr. Pawan Lapsetwar is the chairman for that session. And who's co-chairman? And Professor Mr. A.K. Sahu is the co-chairman. And all the presenters for the second parallel session, they are requested to be present on the first floor, second floor. On second floor in this block. The hall is there.
All the presenters of the technical session 2 are requested to submit their PPTs to the technical team. There is a parallel technical session which is going on third floor. Block A. Second technical session which is going on, second floor. Second floor, Block A, meeting hall. Good morning, everyone. We are here for the commencement of the second technical session of the 57th IVA Convention. Theme of the session is Innovative Technologies in 24/7 Water Supply and Management. In this session, there will be 6 presentations, each of 20 minutes. I request all the presenters to please adhere to the time limit to complete the session on time. I would like to invite the chairperson, Dr. Rajesh Gupta, and co-chair, Dr. Atul Maldure, to the dais. We are honored to introduce Dr. Rajesh Gupta, Professor of Civil Engineering at VNIT Nagpur. He holds a BE from Government Engineering College, Jabalpur, and an MTech in Environmental Engineering from VNIT, a PhD from VRC, Nagpur University, 1996. Dr. Gupta's expertise includes water supply, environmental systems design, water distribution, and wastewater surge analysis. He authored analysis of water distribution networks, contributed chapters to 4 books, and published over 200 research papers, earning 12 Best Paper Awards. He has guided 13 PhD students and 80 plus MTech students. He is a recipient of Jal Nirmalta and Jal Seva Awards for contributions to water quality improvement, and Dr. Gupta is an active member of professional bodies like ASCE, IEI, and IVA, where he served as a national president 2017 to 18. He has completed 250 plus consultancy projects and several R&D initiatives and is currently working on a DST funded project. Dr. Gupta has received international recognition, including a UNESCO Fellowship 2003 and a Visiting International Fellowship 2013.
It's a pleasure to introduce Dr. Atul Vishnupant Maldure, who is a senior scientist at the Water Technology Management Division of CSIR, National Environmental Engineering Research Institute, NEERI, Nagpur. He also serves as an assistant professor at the Academy of Scientific and Innovative Research. Dr. Maldure completed his research at VNIT Nagpur and has held various significant positions in research and industry, including his tenure as a scientist at CSIR Central Glass and Ceramic Research Institute, Kolkata. Dr. Maldure's work focuses on the development of innovative materials and technologies for environmental and water resource management. His expertise spans the creation of refractory materials, carbon-contained refractories, ceramic materials for water treatment, and advanced solutions for the adsorptive removal of pollutants from water. Additionally, he has contributed significantly to evaluating and implementing water treatment technologies in the field, addressing critical issues such as geogenic contamination and water quality assessments for surface and groundwater bodies. Now, I invite Dr. D. Hanumantacharya to welcome Dr. Rajesh Gupta and Dr. Maldure, Atul Maldure, with a bouquet. Now, I would like to hand over the session to the chair and co-chairperson.
Yeah, good morning everyone. We have sixth presentation in this session, and the total time available is 1.5 hours. So I request everyone to finish their presentation in around 12 minutes, so that we get chance for some few question answer. To start with, I request the first presentation, which is by Kashfina Kapadia, on performance evaluation of water distribution network under different leakage scenario through emitter setting. Is she present here, or any other author from that? May I know how many presenters are there, so that we can distribute that time again? Yeah, Kashmira Kapadia, then Anil Maldure, Raghuvanshi Ram, C. Padmakar, and Paras Pujari. Anyone from that is present? You are going. Okay, so yeah. Then Deepak Dahale, yes, he is there. Then Sakshi Sonavane, she is there, yes. Then Shivangi, you are also there. And Gopi Krishnan is also there, so yes. So we have now 5 presentations, so we will have now maybe 15 minutes presentation for each time for each of them. So I request Dr. Atul Maldore to start his this session.
So, good morning everyone. I am Dr. Atul Maldure, working as a principal scientist at NEERI. I am here along with my colleagues, Dr. Kharshe, Dr. Padmakar, Dr. Raghuvanshi Ram. It would be a little bit academic one. The title would be the global standards for the water quality monitoring, including emerging contaminant for the safe water supply. You all know that the Water Technology and Management Division at NEERI is the one of the WHO collaborating center for the water and sanitation. We all know that the Sustainable Development Goals has been set in 2015, and we are working on it. Out of that, one of the strong component is the water and sanitation to everyone, and to get that. To supply sufficient quantity of water with acceptable quality, we all working towards that. And with changing scenario and increasing contamination and the increasing effects of environment, the WHO is routinely publish a drinking water quality manual, and to cover the changing scenario in the water quality, the recent WHO manual has been published in 2021, which try to cover all the emerging contaminants. The main focus of the entire framework entire document is on framework for the safe drinking water, which mostly focus on the water safety plans and the monitoring surveillance aspect. If I look towards the drinking water quality standards in India or all over or in Southeast Asia and India and WHO, there are merely difference between the water quality standard in between. Whereas most of the water quality standards are not based on the health-based data. These values are not based on health data, and that is what the WHO is working right now on all the aspects. So the recent documents is mostly focused on the management and communication, because we are working to provide the sufficient quantity of water, but equally quality is also important, and we are also working to provide the basic quality. If we look to us, this is a like a general water supply system from the catchment area to the household tap. So all we work mostly on the catchment, treatment, distribution, but we can I can assure that the contamination, even the municipal corporation has supply the safe water, the contamination could be happen at our place at the household. This graph will tell you the story. Even though the water is contaminated and it passed through the treatment supply, in the treatment system and supply system, it is not contaminated. Even it can be contaminated at the tap or at the storage at the household. So there are challenges when we provide the safe water from the catchment to tap, like increased anthropogenic activity. So we all know that there are few challenges in the treatment and extraction of the water, and in the distribution there are challenges like leakage and all these things we all know. But once the treated water is getting supplied to at a household, the water quality even can be deteriorated at this point. These few graphs will tell the story. The supplied water at the household is safe, but even the water in the underground sump overhead tank get contaminated, and contamination concentration will get increased. And if we consider the say health, if we calculate the health risk based on the contamination, although it is in safe or it is in moderate level, but yes, it could be severe with time. And the major reasons behind is that the leakages in the sump and the improper maintenance of the underground sump at our houses, and it also leads to cost to the particular person or the household because of leakage, water loss, and in the meter system it calculates the cost. So in addition to that, this is just an example of the microbial contamination, but in addition to that, there are other challenges in the safe water supply, like cyanobacterial blooms, antimicrobial resistance, EMR in the water system, microplastics, climate change, and the protozoa and DBPs, we all know. Mostly we have mostly focused on the sufficient quantity of water, but these are the emerging issues which definitely affect the water supply, safe water supply rather. So harmful algal blooms are not new. We generally know it as a cyanobacterial blooms. So these are there in the water from the ages. But what exactly happened? Why we are talking about the cyanobacterial blooms or algal blooms? Because the increased environmental temperature and enhanced nutrient load in the water body. So these both things categorically or it helps for the growth of these algal blooms. Cyanobacteria are not a bacteria. These are kind of algae present in the water, and these are these are bluish in the color. So that is what is said to be the blue-green algae or the cyanobacteria. So there are n number of reports reported regarding the attack of cyanobacterial blooms on the water bodies. And this is not new in the India. This is not for the India. It's all over. It happens all over the world, and there are reported evidences behind that. So the major reasons behind is the increased anthropogenic activity in the catchment area, nutrient load and enrichment in the water bodies, and the increased environmental temperature. So altogether, it works to have harmful the cyanobacterial blooms in the water body, and the outcome of it, like the fish mortality, because the cyanobacterial bacterial algae, these are the algae, these are photosynthetic algae. During daytime, it goes for the photosynthesis, and during night, it goes for the respiration, and by that way, it consumes the oxygen from the water. So DO will get reduced down mostly during the night time, and it leads to the fish mortality, ecosystem degradation. Obviously, if there is no DO or even the reduced say visibility, so it leads to ecosystem degradation, and obviously if that particular water is being like collected for the drinking or transferred for the drinking, then again it leads to the health issue, because the cyanobacterial algae are the, these are the kind of few cyanobacterial algae reported in India. So these cells have some toxins in it. So once the cell wall get brushed down, it release the cyanotoxins, different kind of cyanotoxins in the water, and these are carcinogenic. Even the WHO has mentioned the limits for these carcinogenic cyanotoxins. These are the color producing, taste producing, as well as these are soluble cyanotoxins present in the water if the cell wall of these algae break down, and that leads to the various health hazards to us. And the issue is that the people will get yellowish water, because during the pre-chlorination or the post-chlorination in the WTP, these cells get dyed and the cell wall get matured, dyed algal grade gives a yellow color to the water, and people reported with the yellow color, and this leads to the various issue during the water supply system. So these are various, these cyanotoxins have various health issues, long-term, short-term health issues are reported.
Yeah, 2 minutes more for you.
Sorry?
Last 2 minutes.
Okay. So, so these are the various guidelines been reported by the WHO for the various cyanotoxins. So challenges in the cyanotoxins are the detection, because there is no standardized protocol for the detection of cyanotoxins, for the detection of the algal growth. The only test kit available is the ELISA test kit, which is very costly. And the challenges in the water treatment plants is the degraded water quality. We cannot remove the cyanobacteria algae in the WTP, because they have buoyancy itself. These algal cells have buoyancy, and they reduce down the the charge, and that is what it is not get removed by the conventional or even the coagulant in the WTP, and it choke down the your filters, the sand media filters, and it also impart the color and taste to the treated waters. So recent WHO guideline only, even though tells the WHO guidelines also mark these things, and they have given the 2 alert levels, that is alert level 1 and alert level 2. And these alert levels also based on the indirect determination of chlorophyll in the water. So if the chlorophyll is 1, you have to take the decision, and you have to take steps to remove them. At the alert level 2, as per guideline, the treatment plant supposed to be stopped, and alternative water supply should be chosen. This is what the this issue to the upcoming issue to the all the water supply system in the all the urban area. Yeah. So based on that, actually these are the issues we are facing in the nearby area, like Latur in the last time, Surat and Solapur last year, in the Vena Dam in the Nagpur and the nearby area. So this is the upcoming issue to be faced by almost all the surface water bodies in the future. This is a gift of the climate change to us. Yeah, thank you.
Thank you, Dr. Maldure. If any question for him?
Sir, actually, because of these higher blooms, the pH get reduced down. So when we go to the WTP, we generally increase the alkalinity of the water, and that leads to the that help to enhance the coagulation or removal of this algal growth in the WTP itself during coagulation process. That's the only step we have. We use lime. We try to. Sorry?
Potash effect on algae, potassium permanganate.
Potassium permanganate will kill down the entire cell. That we don't want, because once the cell get brushed out, the toxins will come out in the water, and these toxins are the carcinogenic. So we never want that the cell wall will get brushed out. Otherwise, we can use the other harsh oxidation process. process like your ozone and all these things. Ozone can surely solve the issue, but it will damage the cell wall. That is not the aim of the treatment.
Any guideline from BIS?
No guideline as such been published by any organization. So we are working, even though my PhD student is working on it, and we successfully in partial UV followed by persulfate treatment. So we are working on that. Even though we have tried the partial ozonation, even though it will work along with the coagulants. So we are trying to find out the solution for this issue.
Yeah. Thank you, Dr. Maldure, for the nice presentation. Yes, please. Now, second presentation in this session is by Mr. Deepak Dahake, and he's going to talk on fast-tracking conversion of intermittent water supply system to 24/7 continuous water supply system by automated package booster pump station.
Respected chair, co-chair, and all water professionals, very good morning to you all. My paper is on fast-tracking conversion of intermediate water supply scheme to 24/7 continuous water supply scheme by automated package booster pump station. So as per the Amrut 2.0 guidelines, the main objectives here, it is the making the cities water secure by providing 24/7 water supply with a drink from tap facility in 500 Amrut cities. And the major reforms covered under the Amrut mission, that is the water conservation, that is the reducing non-revenue water to below 20%, with energy efficient pumping operation by use of smart solution like SCADA, and attaining the sustainability of quality and quantity of water. So with this in mind, we have the customers' expectations. All water utilities are facing this one because the customers is expecting 24/7 equitable supply as and when required. That is the flow as per demand at minimum residual pressure and quality compliant in terms of physical, chemical, and biological. But there are challenges faced by the water utilities, and these are the managing peak demand of the city at a time, handling hourly demand flow fluctuations, because there are a lot of fluctuations as per the peak and off-peak time, and maintaining required pressure at critical point during all these all throughout the day is become very much critical through the gravity feed system. And there are low pressure or no pressure complaints, high non-revenue water losses are getting high, and water quality is not consistent as per standard. So the conversion of this intermittent water supply scheme to 24/7 continuous water supply schemes, and to meet the pressure requirement as per the CPHEO manual, we need to have a booster pump station at the ESR outlet, and then this need the complete civil structure, piping works, everything. So the project timeline goes to 12 to 18 months usually. So, and there is another constraint that these ESRs are situated in the city areas where there is a very limited space for any building constructions, pump house construction, and pipeline layout, new pipeline layout. So we come up with a new concept, that is the skid-mounted pumping station, where it is compact in size with all the required piping pumps and piping layout. And the project period can be reduced to 4 months, and which can fast track the conversion of intermediate water supply to continuous water supply. And this package booster pumping station include pump, motor, VFD panel, and SCADA system on its own. And this ensures energy efficient automated operation with smart pump control philosophy. But while designing this package pumping stations, There are some critical parameters we need to consider. And this includes this compact assembly with proper maintenance access, and vibration, resonance, structural fatigue, and stress on material, which can impact the longevity and efficiency of the skid and all this equipment. The selection of pump and its material of construction is very much critical, because it will affect the sustainable and efficient operation in long-term period. Then the piping layout and other fittings. And we need to conduct the modal and harmonic analysis to identify and mitigate vibration-related issues, CFD analysis to enhance fluid flow dynamics and pressure distribution. So this is the typical demand profile and pressure requirement you can see. Where in this graph, you can see the three time zones. The bottom below one is the current demand profile, then after 5 years, and the projection is after 10 years. So these are the three timelines the demand profile is drawn, and the pressure required at the ESR outlet is shown in different color. So you can see the demand is changing every hour, and accordingly, the pump need to be designed. So if our pump life, our design life is 15 years, so with this time horizon, the bottom straight line you can see this is the minimum demand, and the top one is the maximum. So all your pumps operating zone and the number of pumps, duty configuration, everything should be within that range. So on the right side you can see the proposed pump where all these demands can be covered by 3+1 duty configuration. And this is how the skids are going through the technical analysis and engineering works, where this 3D model is developed, and then this model analysis is conducted, and then harmonic analysis and CFD analysis. And these skids comes in different layout as per the requirement and the pumps. And this is how we can see the ESR, and on the ESR outlet, these skids can be connected, and we can connect 2 skids if required. And there are options to cover the skid with the shade or room. The room is also a prefabricated room with cement sheet and fireproof insulation material. So all this structure can be fabricated and commissioned within 4 months. And the SCADA part of this system covers everything as per the demand. So the system checks the demand every minute and adjusts the system pressure as per the designed or expected system head curve based on the critical point requirement. And you can see the pump operating point live, real-time basis, where the pump is operating, what is the system efficiency, everything can be configured, it is SCADA adjustable. And the pressure fluctuation we can see, in case of the gravity feed system supply from the ESR, see in the left-hand side, the red line refers to the pressure from the ESR, and the blue is the flow fluctuation, and similarly, the bottom one is the residual pressure fluctuation in the network at the critical point. But in case of the direct feed network, your rising main pressure and the flow goes hand in hand. So your residual pressure is very much uniform within ±1 meter. And this will reduce your losses, and because of this fluctuation, the breakdowns also gets reduced. And additional benefit is that you are just giving the pressure as much required. So we are optimizing the energy consumption and reduce carbon emission.
Last 2 minutes, sir.
So this is the energy saving potential with the VFD for the direct feed network. And this is the just case for the 100 kW system, where we can say that annual energy saving, we can get 295,000 kilowatt hour, which is equivalent to the carbon emission of 214 ton per year. But not only this one, when you increase the pressure to 17 to 21, the household connections who are using their small half HP pumps to lift the water to their terrace tank. So I consider only 50% of home may stop using this one. So for this 100 kW system, there will be around 10 to 12,000 homes. So out of this, 6,000 homes, if they stop using their pumps, 0.5 HP pump, even for half an hour, 15-minute morning and 15-minute evening, so we can save 408,000 kilowatt hour annually, which is equivalent to 296 million ton of carbon dioxide. So this is the saving when we achieve the pressure as per the CPHO guidelines. And this is the timeline for the project where all these mechanical, electrical, civil and PLC SCADA work can be finished within 16 weeks period. So in conclusion, the skid-mounted booster pumping station comes as a plug-and-play, ready-to-commission system in auto mode, and it eliminates human error in operation, reduce pressure surges, which results in reduction in burst frequency, and optimized network pressure reduces NRW and saving energy with efficient system operation, and it prolongs asset life, reduces maintenance, and reduces life cycle costs also. So well-designed skid-mounted package booster pumping station can speed up the AMRUT 2 mission projects with sustainable operation. These are the references. Thank you.
Thank you, Mr. Dahake. Any question for him? Fine. So thank you very much for the nice presentation on the variable speed. Yeah.
Overhead service reservoirs, and some of the portion is not covered with the OHSRs.
Okay.
Say 5,000, 10,000 houses. Can this booster pump kind of thing can cover whole city as a 24/7?
Yeah,
This
we
is
can
first
cover.
question.
Yeah.
Second question is, you have analyzed there is an energy saving to a considerable amount. Is there any practical study over it, ki how much it has been practically possible, or it is a theory?
Yes.
And there is a behavior change in the public. When we give 24/7 water supply, it develops the trust in the mind of the people. They do not conserve the water, store the water, and they use less water. Is there any study how much time it takes over the mind of people for uses, judicious uses of the water when we convert it to the 24/7? Thank you.
Sir, regarding this ESR or without ESR, the system can work on both way. So for with ESR, we need to boost the pressure. So as per the pressure requirement only, it will boost. It may boost for 5 to 10 meter, 15 meter, but real-time basis, every minute it change. Without ESR, the system will work with the same way, and as long as you have the inlet supply as per the demand, fulfilling the demand, the pressure will be applied to the system as per the demand only. It will not over-pressurize the system. So it works both way. Second thing, the stabilization period for the after conversion, because the customers will be used to that 24/7 guaranteed supply, it may take 1 month period, around 3 to 4 weeks for them to stabilize. So, but first 2 months, you may get some erratic flow requirement, and that is to be balanced through your MBR or like this. So this is the condition. Regarding the energy conservation, I have seen this with my 15 years of experience in Gulf, where I commissioned more than 45 projects for this 24/7. So minimum 35% energy saving is possible. And this is documented in the international conferences also.
Yeah, Dr. Harmanchari.
Yes.
How you are taking care of the variable flow during peak factor, peak hours with the pumping?
Peak factor?
How you are taking care of peak supply? how you are taking care of peak supply
Yeah.
by pumping, by booster pumps? Is it, you are, how you are going to pump, I mean, variable pumping or how?
Sir, usually once the system is stabilized, your peak factor will reduce. Currently, in the gravity conventional system, we are taking 2.5, and with this demand profile. But actually, it is seen that it comes to 1.5 to 2, depend on the customer's mixed use. If it is a pure residential or commercial plus residential or industrial commercial residential, depend on the group of customers, your peaks are changing. But it comes within 1.5 to 2 once it is 24/7.
So, thank you,
Thank you,
Mr.
sir.
Dhake. Yeah.
Thank you.
Now the next presentation is by Sakshi Sonamane, and she is going to talk on the multi-objective optimization of water distribution network using variance of flow as a surrogate measure. So 15 minutes for you, Sakshi.
Good afternoon, everyone. My name is Sakshi Sonavane and I am from VNIT Nagpur. Today, the topic of my presentation is multi-objective optimization of water distribution networks using variance of pipe flow as a reliability surrogate measure. These are the contents of my presentation. Water distribution systems are a critical part of urban infrastructure, and an efficient water distribution system is that which can supply sufficient quantity of water with proper quality and quantity and adequate pressure at all times. The water distribution systems are often experience partial or complete failure over its lifespan due to various reasons like demand exceedance or component failures, and hence assessing the system performance under various failure scenarios is essential. This brings us to the concept of reliability. Reliability is the capability of the system to overcome failure while still satisfying the demands and pressures at the nodes. Over the time, various reliability analysis methods have been developed, like Monte Carlo simulation, minimum cut set method, node availability method, etc. But these existing methods are computationally intensive and time consuming. The implementation of reliability in water distribution system design becomes a two-step methodology, where in the first step, we optimize the cost, which results in a network with low reliability because cost and reliability are two contradicting objectives. Then reliability assessment is done and we adjust the pipe diameters to increase the reliability. This process is continued iteratively until the desired reliability is obtained. As quantified measures of reliability are particularly difficult to define and evaluate, it is even more difficult to incorporate reliability in the design of water distribution system, and hence reliability surrogate measures were adopted. These surrogate techniques do not compute reliability of a system directly, rather they assess some attributes or measures of water distribution system which are expected to have a strong correlation with reliability. Some of the common RSMs used are resilience index, flow entropy, network resilience, etc. These reduce the computational time and also achieve near optimal solutions even when multiple objectives are being considered during the design. These RSMs perform differently under hydraulic and mechanical failures. For example, when the networks optimized using resilience index, they are reliable and cost-effective for hydraulic failures, but do not perform well in mechanical failures. To overcome this, network resilience index can be used, but it is found suitable for smaller networks. Flow entropy handles mechanical failures better, but are less reliable for hydraulic and water quality failures. It works well for dense networks. Overall, flow-based RSMs were found to be more consistent in their performance. Flow variance as a reliability surrogate measure. Variance of flow distribution indicates the closeness of flow values in different pipes. And as the variance of the network decreases, reliability of the network increases. As like in an event of a pipe failure, downstream users are affected as the adjacent pipes are not made to carry such high flow rates. Conversely, if the flow is uniformly distributed across all pipes, and there is minimal variance, then any single pipe failure would not affect the network performance much. And a bi-objective optimization was done in the present study, where the two objectives considered are cost minimization and flow variance minimization, and Rao-2 algorithm was used for the optimization. Rao algorithm. It is a meta-heuristic algorithm which is inspired by simple mathematical principles rather than any natural processes. It requires no algorithm-specific parameters, therefore there is no need for parameter tuning, and it simplifies the implementation. It uses basic mathematical operations to update the next population, and Rao-2 avoids being biased towards extreme solutions as it incorporates random solutions to update the population, leading to better exploration and less chances of stagnation. This is the formulation of optimization model where there is minimization of cost and minimization of flow variance. Since water distribution system design is a constraint problem, these are the constraints that have to be satisfied during its design. This is the methodology which was used. First, we generate an initial population and then discretize the diameters to the commercially available diameters. Then the generated population is given to EPANET tools for hydraulic analysis via Python. And we obtain the head pressure and flow through pipes. And then we calculate the flow variance and total cost of the population. And we impose a penalty on those solutions which are violating the constraint. Then we classify the solutions into dominated and non-dominated and also calculate the crowding distance. We identify the best and worst solution using the concept of ideal and nadir point by calculating the Euclidean distance of those points from the solution. And then using the best and worst solutions, we update the population using Rao-2 equation. Then again we run the hydraulic analysis and calculate total cost and flow and apply penalty on infeasible solutions. Then we combine the initial population and the updated population and classify it into dominated and non-dominated. And we select the best end solutions. Yes, sir? Okay. Yes, sir. So we report the optimum when the criteria is met. The proposed algorithm was applied on a two-loop benchmark network, and an initial population of 200 was taken, and the program was run for 2000 iterations. We obtained a population of 40 non-dominated solutions. These are some of the non-dominated solutions which we obtained, where total cost, flow variance, and the diameters corresponding are given. Pallod and Gupta 2024 also minimized pipe flow variance and network cost using Jaya algorithm, but here a priori optimization was applied by assigning weights to pipe flow and network cost. And here each simulation produced a single solution, therefore the program has to be run for varying multiple runs with varying weights to total cost and variance to generate a complete Pareto front, as opposed to the present study where we can obtain a Pareto front in a single run. The table 2 shows some of the similar solutions that we obtained in both the studies. The previous studies used a two-step methodology corresponding to minimum cost and variance, but in this study we are optimizing cost and variance simultaneously. Single step reduces cost and variance, and we also achieved the global variance that is reported in the literature, and a complete Pareto front was obtained in a single run. These are the references. Thank you.
Thank you, Sakshi. And few questions for her. Okay, so thank you, Sakshi, for the nice presentation. Now we move to the next presentation, which is by Shivangi Sharma, again from VNIT. She is going to present on a review of the application of clustering in water distribution network.
Good afternoon, everyone. My name is Shivangi Sharma, and my topic of presentation is review of the application of clustering in various areas of water distribution networks. So this is the content list. So WDNs are large and complex infrastructures, urban infrastructures consisting of thousands of components such as pipes, walls, junctions, etc. And they span over a huge area. And their primary function is to supply water at adequate pressure with good quality and quantity. So, but due to rapid urban development, the WDNs are continuously expanding, and due to this, their complexity is increasing. And it is becoming difficult to analyze such huge networks. So, and the issues which are occurring in WDNs are leakage, contamination, pressure imbalances, and etc. So identification and finding solutions to these problems requires simplification of the network, and clustering helps in the simplification of the network. So objectives of the study are to explore the different types of clustering methods and algorithms which are used in WDNs, and to understand the different objectives for which the clustering has been applied, and to search various areas of WDNs where clustering has been applied, and to review the concept of clustering. So what is clustering? Clustering is an unsupervised approach of machine learning and data analysis. It groups the objects into clusters based on some similarity measure. So grouping is such that the objects of the same in the same cluster are more similar to each other than to those in the other clusters. And it splits the networks into subnetworks or clusters so that the intricate network structure and interaction between its components becomes understandable. So in WDNs, clustering is applied for the complexity reduction, which helps in their easier analysis. So there are different methods of clustering. So first one is hierarchical or connectivity-based clustering method. Based on proximity distance, here clustering is done of an object with its neighbors, and similar objects having minimal distance fall in the same cluster. And the clusters are present as dendrograms. Hierarchical clustering is of two types: divisive and agglomerative. Divisive is top-down approach, in which all the data points are considered to belong to one large cluster, and that large cluster is divided into smaller subclusters. And in agglomerative or bottom-up approach, each data point is considered as a cluster itself and is combined iteratively into fewer number of clusters. Then another method is partition-based or centroid-based clustering. It is simple and easy, easiest of all, and it works on the closeness of the data points to the chosen central value. And it requires predefining of the number of clusters at the initial stage. Examples are k-means, k-medoids, and Clara algorithms. Then another one is density-based or model-based. Here, density is considered ahead of distance for clustering. The regions where the data points are high in concentrations are clustered together, and these are bounded by regions of lower concentrations of data points. Then here clusters vary in the arbitrary shapes and sizes, and because of their maximum homogeneity. And it includes noise and outliers in the data sets effectively. Examples are dbScan and optics algorithms. Distribution-based clustering. In this, clustering is based on the likelihood of data points to to belong to some same probability distribution in the data. The cluster includes the data objects that have higher probability to be in it. Then another one is fuzzy clustering. It's a generalized form of partition-based clustering only, where a data object is able to be a part of more than one cluster. And it handles the situations where the data points are somewhat in between the cluster centers. And here example is fuzzy C-means clustering. In constraint-based or supervised clustering, it incorporates domain-specific constraints into the clustering process, and it is often used when traditional algorithms are not able to account for the specific requirements in the data. And the last one is graph theory-based clustering algorithms. So graph theory is a branch of mathematics that studies the relationships between the objects using graphs. So a graph is a mathematical representation consisting of nodes and edges that connect the pair of nodes. So these methods focus on identifying densely connected subgraphs within a network while minimizing the inter-community connections. So examples are DFS, BFS, Louvain algorithm, fast-greedy algorithm, spectral algorithm, etc. So my review, these are some areas where I've searched for various algorithms which are applied. So in this, first one is district metered areas formation. So in the first study, they used breadth first search algorithm and Dijikrah's algorithm to reduce the network complexity And the clustering concept used was adjacency matrix and flow-weighted adjacency matrix. And in the second study, authors used recursive spectral clustering algorithm, which uses graph Laplacian matrix for clustering the network. And here the objectives were network simplification and to get topologically optimal clusters. Then another application is analysis of WDN. Here in the first study, depth first search and breadth first search algorithms were used, and the concept used were strongly connected components and weakly connected components. Objectives were to simplify the network and to get strong interconnected clusters. And in the second study, they used depth first search algorithm, and again the same concept was used, strongly connected components. And the objectives were network aggregation and network simplification. Another application area is calibration. Here K-means clustering algorithm was used, and clustering was done on the basis of pipe features like age, material, diameter, and diameter. And objectives were to reduce the number of variables of the calibration problem and to reduce the degree of freedom of the calibration problem and error minimization. In the second study, multi-view K-means clustering algorithm was used. Concept used was node characteristics such as pressure sensitivity to roughness and leakage events. Clustering objectives were to determine the number and arrangement of sensors and to reduce the decision space. Then another application is pressure sensor placement. Here, in the first study, K-means algorithm was used, and concept used was pressure sensitivity matrix. And objectives were to reduce the network complexity, to optimize pressure sensor placement, and to determine optimal location of sensors. And in the second study, they used spectral clustering algorithm, which uses graph Laplacian matrix for clustering. And again, the objectives were network simplification and to reduce the computational burden in the next optimization step. Then another application is leakage detection and localization. In the first study, spectral clustering algorithm again was used, and it uses graph Laplacian matrix, and objective was to simplify the network. In the second study, they used hierarchical clustering algorithm and K-means clustering algorithm, and used spatial distance between the nodes to cluster the networks. And objective was to simplify the network for efficient leakage localization. Then another area is critical pipes identification and rehabilitation. Here clustering algorithm used was modularity-based Newman algorithm, which works on modularity to cluster the network. And objective was to simplify the network and to get clusters which have strong internal connections. Then in the second study, they used modularity-based clustering technique implemented using Gephi software, and it again works on modularity. And objective was to reduce the complexity of the rehabilitation problem and to simplify the WDN network to analyze closely the interactions between the network components. Then another application is demand estimation. Here self-organizing map clustering algorithm was used, and concept used was sensitivities of measurements to changes in nodal demands. And objectives were to reduce the unknown demands to be estimated from the limited number of measurement locations. Then another application is operation and maintenance. Here DFS and BFS were used, and again the same earlier concept was used, strongly connected components and weakly connected components. Objectives were to simplify the network and to get strong interconnected clusters. Then another application is contamination event detection, quality analysis and sensor placement. Here they used, in the first study the authors used edge betweenness community algorithm and K-means algorithm, and the clustering concept was used was betweenness centrality, eigenvector centrality, closeness centrality, and page rank. And the objectives were to simplify the network and to optimize the number and location of the sensors. In the second study, they used harmonic search evolutionary algorithm, optimization algorithm with K-means. And they used spatial similarity to cluster the network, and here Jacquard's similarity index was used. And here the objectives were to group contamination events based on spatial similarity in their propagation regimes, and to for sensor placement at the centers of the clusters identified. And the last application is decentralization and intermittent water supply. So in the first one, they use K-means clustering algorithm, which uses Euclidean distance for clustering, and objectives were minimization of the source demand distance and maximization of intra-cluster homogeneity. And in the second one, modularity-based clustering algorithm was used, and it works on modularity only. And objectives were to simplify the network and to have clusters having good connectivity. So the conclusion is that that clustering has.
It's an increasing the pressure. So that scenario is there.
Thank you, sir.
In Amritsar, I am in charge of the project. In Amritsar, project is going on. That is a switching over from the groundwater supply to canal water supply. That's a 440 MLD project. It is under construction. It's to be completed in a year. And we have taken 10,000 connection as a pilot project for 24/7. Project is prepared and it will be started next month.
Thank you,
The
sir.
ultimate goal is Amritsar is to be 24/7 in next 2 years.
Thank you, sir. Thank you. Yes, sir. Play mic, please.
Okay, one or two more question. He answered it. It is a
Consumer connection also HDPE pipes. Previously, consumer connection was the property of the consumer. Now, under the project, we are renewing all the consumer connections and meters. Under the scope of the project, we are using HDPE, 20 mm HDPE pipes. Audible, not audible, sir.
For 24/7, it is necessary to replace all old pipes, ACPVs.
Yes, sir. All as per other pipes like asbestos cement or PVC pipes, they have to be replaced because they are found mostly leak prone. We have replaced all the asbestos and PVC pipes and replacing it with high density polyethylene pipes if the size is less than 300 mm and ductile iron pipes above 300 mm.
No, my question is, it is necessary.
Yes, sir. Our experience, the PVC pipes and the AC pipes are prone to leak. We cannot ensure continued pressurized supply with those pipes.
Our PVC pipe or AC pipe are of highest standard. How we can say they cannot sustain?
They are as per standard, but that standard is not adequate to meet our pressure requirement.
No, no. A PVC pipe of 4 kg, it can sustain 160 meter. No city has so level difference.
But field experience is different, sir.
Tamping can be done at HDPE.
HDPE requires specialized equipment. It's not available locally, common.
At DI pipe, it can be done.
so okay. I think
Yeah, anyway, they are much complicated than a PVC pipe.
I can just,
Gopal Krishnanji,
I can
think,
just add one line.
let us not discuss about the pipe material. It is going to raise some.
question is only
Whatever
it
is
is
was
necessary.
done, he has presented it. It depends on that condition to condition, and whatever that his experiences that he has shown. Okay.
Thank you, sir.
So I think now we have come to the end of this session. All the presentations are over.
Sir, I'm having a question. Sir, sir, kindly let us brief some of the facilities which a customer avail from your customer facility center, sir.
Pardon?
Sir, kindly brief us the facilities which a customer avail from your customer facility center.
Customer facility center, a customer can get information of his water charges billing and other things. He can give a new application form for new connections, and also customer facility center has the collection facility. I say that anytime cash payment machine is there, 24 hours open, and there are counters for receiving the payments. Customer can, in addition to the customer facility center, sir, thank you, we gave a dedicated helpline number for customer contact. We gave a WhatsApp number through which consumer can make complaint any time, which will be acknowledged immediately with a receipt number and will be attended within 24 hours. That facility is also available, which I failed to mention. Thank you for.
Okay, so thank you, Gopal Krishnanji. Very nice presentation and a lot of discussion on that. So In fact, out of the 6, that 5 presentations were there in this session, Dr. Atul Maldure talked about the emerging contaminants and the global standards for the water quality monitoring. Then in the second presentation, Deepak Dahakeji, that he talked about the variable speed pump and how the intermittent water system can be expedited to convert, while converting to the continuous system using these automated package booster pumps. Then by-objective optimization technique was discussed by Sakshi Sunamane, wherein that she talked about the cost and the reliability aspect, both the aspects, and try to give a solution which is having a better reliability using some surrogate measure. Then Shivangi, that she talked about the various clustering methodology and where these are applied in the distribution network. And in the last presentation, Dr. Gopal Krishnan, that he talked about the success story of the Coimbatore Water 24 by water supply system, which is based on the PP model, and the present status was presented by him. So from our side now, the session is over and it is handed over to the organizers. Anything, Dr. Maldure, you want to add?
Yeah, all things are covered by Gupta sir.
So, thank you everyone. So as we conclude this session, I would like to invite Dr. D. Hanumantacharya to felicitate Dr. Rajesh Gupta and Dr. Atul Maldure with a memento and shawl. All the presenters are also requested to come on stage. Mr. Deepak D. Dahake, Sakshi Sunamane, and Dr. P. Gopalakrishnan. next session will start at 2:30 after lunch break.